In this video, we're going to review how to compute an average, or in other words, a mean. When we compute an average or a mean, we're talking about finding a measure of center. Specifically, we want to take all data values into account. You can kind of think of this as like a people pleaser. We need to speak to every single data value. We don't want to leave anyone out. We want to be very, very inclusive. This is why computing an average or a mean, this is known as a sensitive statistic. If you kind of, again, think of a people pleaser, that individual is very sensitive and wants to make sure that everyone gets a chance to talk and that no one gets ignored. As a quick refresher, to calculate, we want to add up all the data values that we have in our collection, or what we would also call a set, and divide the sum by the count of data values that we have available to us. What you see below on the page is a general formula. So we have mu, which is a Greek letter used to represent average or mean, and this is going to be equal to, we have the Greek letter sigma, which stands for summation, or in other words, it's saying to add everything up. And if you notice, underneath summation, we have I going from 1 to n. So this is the very general construction. And basically what we are saying is you want to add up every single data value from the first data point all the way to the last one, which we consider or call the nth data point. We use n because not every set has the same number of data values in it, so we use n to kind of indicate this is the largest value. Then we're going to divide that by n, which I had just said is the highest count of our data value. So let's go ahead and take a look at an example. Say we have the following data set. So we have -17, -3, 0, 1, 4, 5, 15, 19, 21, 27, 34, and 56. So the first thing that we should do is add up all of these data points. So we would have something like this. The next thing we would want to do is count and make sure that we know how many total data points we have in this set or this collection. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are going to take our full summation and we're going to divide that by 12. Before we go any further, please note 0 does count as a data point, so that is why we have a total of 12. Adding up what we have in the numerator, we will get 167. And then again, we will divide that by 12. And in this case, we are going to get 13.916 repeating. In other words, we just see a string of sixes. So in order to kind of cut that a little bit short in my presentation, I'm going to put a bar over the 6 to indicate that number goes on indefinitely. I also wanted to take a moment to show you what this would look like visually. So say we have the following data set, 0, 1, 3, 5, 5, 8, 9, 12, 13, 13. And if we calculate the mean, we would end up getting around 6.9. In this case, we can see, as I have it highlighted with the orange dot, our average or our mean is going to be kind of balanced in the middle. If you notice, we kind of have the same amount of lower numbers as we do larger numbers. So this is why that mean, or that orange point, is situated in the middle. However, say I have a lot of smaller valued numbers and maybe just 1 or 2 larger valued numbers by comparison. So with this data set, 0, 1, 1, 2, 2, 2, 2, 3, 11, and 14. So again, take a look at how the blue dots fall on this dot plot. And we find that our average ends up being 3.8. Notice that the mean value is gravitating more towards the smaller numbers. And again, this is because the mean is a sensitive statistic. It's going to travel where you kind of see more of the common groups or that common voice. In this case, we have a lot of smaller numbers, so it's going to begin to pull itself closer to them. Not surprisingly, if we flipped this script and say we had just a few smaller values and a lot more larger values, like this data set, 3, 4, 4, 10, 11, 11, 13, 13, 13, 14. Again, this time, because there are a bigger collection of larger numbers, it's not surprising that our mean is going to gravitate over towards them a little bit more. So one of the main takeaways that I want you to note is that the mean is not necessarily going to always be perfectly balanced like we saw in that first dot plot. Sometimes if you have more of a certain type of number, so in other words, more of the smaller numbers versus larger numbers, we're going to see the mean go where, for lack of a better term, where all the action is, or where the bigger crowd is. It's going to go to where most of the voices or people are living. Kind of like, I guess, a politician trying to get a vote. They're going to try to skew their campaigns towards the larger population in order to get their vote. Now I'd like you to take a moment and give this a try. So go ahead and calculate the average, or in other words, the mean, from the following data set. When you are ready, go ahead and pause the video, work everything out, and once you are done, press play and we will review this together. Okay, so taking your data set, we are going to go ahead and add up every single data point. And since we have 16 data points in this set, we are going to divide that sum by 16. This is going to give us 598 divided by 16, which when we divide that, that will give us 37.375.